Okay, so we already finished displacement in 1D and 2D, and we already finished distance as well, and we also finished two more things. What are the things that depend on time? Two things. What are they? Velocity and velocity and speed. So basically, this worksheet right here, worksheet number 5, depends on what or covers velocity and speed as well. Make sure you look at the video and also look at the handout. Oh, sorry, the solution. Okay, so in reality, it's very difficult for any object, no matter how small or how large or what the object is, to maintain a constant what? A constant speed of motion. Everything either what does one of three things. You could either what? Speed up, slow down, or what? Turn or change direction. Exactly. We're gonna do these three cases. In grade 11, we only did two cases. We either did what? Speed up or slow down. We did not do what? We did not do change direction. In grade 11, because we should be so used to all directions, basically, we are doing what? We are doing turning. We are doing change direction. So by speeding up, slowing down, or turning, a new physical quantity called acceleration is defined. Go ahead, copy. Okay, acceleration is defined. Here's what you have to understand about the word acceleration. Okay, technically, in English, what does it mean to accelerate? It only means one thing, which is what? To what? To only what? Speed up. However, in physics, it could mean both speeding up and slowing down. Okay, so it's what we call like a misnomer, but this is just how the word is. So there is only one physical term used in physics, which is acceleration, even if the object is slowing down. There is no quantity given a name of deceleration. You can use the word as a communication or a therefore statement if you like to actually describe what's going on, but there is no actual symbol for deceleration. The only thing we talk about in physics is acceleration, even if the object is losing speed, even if the object is slowing down. Okay, so you can use the word, but there is no physical symbol for it. Okay, so here's another way to think of acceleration, and this will really hit home to everyone here taking calculus, or even if you did grade 12 advanced functions. It is named or it's called the rate of change. How many people heard of rate of change? Yep. Every single time in science or math, you relate something to time, you are talking about rate of change. So think of acceleration, or acceleration should be viewed as the rate of change, the rate of change in, now this is important. It's the rate of change in what? In what? Velocity, not speed. It's very important to understand this, everyone. It's the rate of change in velocity, not the rate of change in speed. Okay, this is going to be very important. So either positively or negatively. So what does that mean? If your rate of change in velocity is positive, this is our good old friend acceleration. If that rate of change in velocity is negative, it is technically what? Deceleration, but we still call it what? Acceleration or negative acceleration. Okay, get used to this idea of negative acceleration. We're going to deal with it a lot in this course. Sorry, not just in this unit. Yes, in unit 1 and 2 and 3 and so on. Okay, so that's basically the conceptual understanding of acceleration. Okay, all right, let's go to the next slide. Okay. So the physical symbol for acceleration is what? What's the physical symbol? Is it uppercase or lowercase? Lowercase. Okay, lowercase. However, because acceleration is defined, as Ali said, in terms of velocity, which is itself is a what? Vector, then that means what? Acceleration is also a vector. So now you know, if I ever ask you for acceleration, technically I want both what? Magnitude and direction. And also technically now, because it could be positive or negative, if it's negative, you have to show the what? You have to show what sign? You have to show the negative sign in your answer. You have to show the negative sign in your answer. Okay? By the way, it's always easy to remember which one is a vector, which one is a scalar. Velocity starts with V, so it's a vector. Speed starts with S, so it's a scalar. Always remember that. Okay? So acceleration is divided in terms of velocity, which means it itself also has to be a vector. Okay? So the physical symbol for acceleration is simply lowercase a. Is there such a thing as an uppercase A in physics? Of course there is, but we don't use it in this course. Okay? It actually has to do something with electricity and magnetism. You do not even need to know that it exists. Always lowercase a, please. Even in the university physics, it's always got to be lowercase a. Okay? All right. So it must have a direction. It must have a direction. All right. The standard physical unit of average acceleration is meter per second squared. Hold on. I will explain what that means, but once we actually give you the equation or the formula. Okay? So the standard physical unit of average acceleration is the meter per second squared. What do you measure using only meter per second? Just meters per second? No, distance is the meters, either speed or velocity. Okay, so also remember, meter per second is either velocity or speed. When you make it meter per second squared, there's only one object in the universe, sorry, one quantity in the universe measured with that, and it is acceleration. Acceleration. Okay, so how could you write meter per second squared? Well, it is a per, so we need the what? Need the what? The slash. So either way, everyone, if you're doing some unit conversion, please write it like this because you need to see it as a full-fledged fraction. If you're writing it as a final answer, then you are more than welcome, actually encouraged, to write it as meter per or slash second squared. Okay, and that would be final answer form. By the way, you might be asking now, am I ever going to give you a question where I ask you to switch, for example, listen up. I ask you to switch acceleration from, let's say, kilometers per hour squared to meters per second squared? No. If you want to switch units with acceleration, don't switch it like that. Switch it from the what? Switch it from the what? From the beginning in the problem itself. Do you see what I mean? So, for example, if I gave you a problem in kilometers and hours, in kilometers and hours, and I'm asking you to find acceleration in what? In what? Meters per second squared. Don't do the whole problem in kilometers per hour. Get your acceleration in kilometers per hour what? Squared, and then convert it to what? No. Switch it already in the problem to what? Switch your kilometers to what? Meters. Switch your hours to what? And then you don't have to what? You don't have to switch it at the end. Always switch things at the beginning. It's much easier than switching a what? A quadratic unit like a second square. Okay? Trust me, it's got to be much easier for you. Okay. So this is the mathematical formula, everyone. The average acceleration of an object is always how much did the velocity change over how much did the time change. Okay, so how much did the velocity change over how much time it took to achieve that change in velocity. Always remember, acceleration is meaningless if you don't give me time. Acceleration is meaningless if you don't give me time. I'll give you an example. Let's say you're describing a car on the highway and you say um, that car accelerated from 100 kilometers per hour to 120 kilometers per hour. What am I missing in my information? Remember, I only told you that car went from a velocity or a speed of 100 kilometers per hour to 120 kilometers per hour. What did I not tell you? I did not tell you how long it took it to do that. It could have done that in a minute. It could have done that in what? In 2 seconds, in 2 minutes, in 2 hours. By the way, which one is more accelerating if you do it over a short period of time or a long period of time? Short period of time. Short period of time. Why? Because look at the equation. If this guy is small, what happens to the whole fraction? Keeping the top the same. What happens to any fraction if you keep the top the same, but you minimize the bottom? What happens to the whole fraction value? Does it get smaller or bigger? Exactly, yes. So that means you have a higher acceleration or a higher speeding up rate, or I guess a slowing down rate if you lost speed. Okay? So I'm going to give you two equations for acceleration. Either that one, the delta V, sorry, my bad. Either the delta V over delta T or the detailed equation, which is what? What does delta always mean? Final minus, which is the same as what? Can you ever do initial minus final? No. Why? Because even when you time things, final always comes after initial. Okay, so always make sure you always do final minus initial. By the way, I'm always be revisiting this point because so many people think that delta or change is always what? The bigger minus the what? No, it's the final minus the what? It doesn't matter which one is big, which one is small. By the way, if it's always bigger minus smaller, your answer is always going to come out to what? Negative or positive. But we know that change could be what? Exactly. That's the whole point. Yes. So notice that we're subtracting vectors now, not adding them. This is very important. This is actually the main difference between acceleration and displacement. In displacement, you added a bunch of vectors. In acceleration, you subtract them. You subtract them. Okay. So let me actually tell you. Okay, what was the equation again for acceleration? What per what? What per what? Standard, standard. It could be anything, but the standard units are what? Meters per. Okay, how did it actually come out to be meters per second squared? Okay, everyone, let's actually derive the unit. Okay, so how do you measure velocity? In what unit? Velocity. Standard. Meters per. By the way, if you say meters, you're not measuring velocity. You're only measuring what? Distance or displacement. Thank you. So if you're going to measure velocity, you're going to measure it in meters per what? Second. And if you're going to measure time, you're going to measure it in what? Second. Okay, so let's divide meters per second divided by second. How can I deal with this fraction? How can I simplify this? How many people know what to do here? In a way, I'm dividing fraction. So what should I always do? Ahmed, what should I show? Where is the second fraction? I only see one fraction on the top. Exactly. See, you don't see it as a fraction over a fraction because you did not show the what? You did not show the 1. And now we can actually what? Divide. How do you divide fractions? What do you flip? The top or the bottom one? The bottom, because it's always the second after the division sign. So equals meters per second divided by second over 1, which is meters per second, times what? 1 over second. And how do you multiply fractions? Do you crisscross or do you level multiply? When you multiply fractions, top with top, bottom with bottom. So what's meters times 1? Meters over second squared. That's it. That's basically why we call it meters per second squared. Okay? Understanding this derivation basically hinges on the fact that you understood where each unit came from here. Okay? All right. Okay, so let's do a quick example here. Consider the car below, which you have already in your notes. So you have a car going some direction. We don't really care what it is. Let's say it's north. So consider the car below, which is currently moving at a speed right now. When you open your eyes, you see it pass in front of you at a speed of 73 kilometers per hour. Someone is telling you the driver is pressing the gas such that they're what? They're accelerating at a rate of 5 kilometers per hour squared. Can someone tell me what's another way to say 5 kilometers per hour squared? If I don't want to say it hour squared, what's another way to say that? Who remembers it from grade 11? What's another way to phrase 5 kilometers per hour squared? Wadah, how could you say it? Not, okay, you're missing something. Everyone, listen. Say it again. He said 5 kilometers every hour. He's missing something. I'll give you a hint. If you're saying 5 kilometers every hour, you're describing speed. I want you to describe acceleration. Who remembers it from good? Okay, Hamad. 5 kilometers per hour every single what? Every single hour. So every single hour that passes, that car is gaining how much speed? 5 kilometers. Okay, I am noticing there's a trend here. Some people are saying it's gaining a speed of 5 kilometers. Does that sentence make sense? No, because what do you only measure using kilometers? Distance. So you cannot say it's gaining a speed of 5 kilometers. You have to say it's gaining a speed of what? 5 kilometers per hour for every single That's how you say it, okay? That's it. You basically have to say the hour twice, okay? That's the whole idea. So that means what would be the new speed there if you only gave it 1 hour of time? Because you only are allowed to gain how much? 5. And obviously, are you gaining or losing speed? Is it because I'm using the word accelerating, or is it because of the number 5 itself? Exactly. I could have said accelerating at a rate of what? And that would mean it's losing speed, so it would be 68 kilometers per hour. Okay? So always remember, it's not the word, it's the sign. Perfect. How about this one? 2 hours from the second moment. Because it's 5 plus 5, assuming the rate was kept the same. Perfect. Okay? No need to calculate because it's basically a conceptual exercise here. All right. Now let's talk about two kinds of motion. Very important. Uniform motion and uniform acceleration. Okay? So, kinematically speaking, there cannot be more than two or other than two kinds of motion in which we are interested. Either uniform motion. In uniform motion, what does that mean? If an object is moving in front of you in a uniform motion style, what does that mean? Say again? Cruise control. When you remembered from what grade 11, I always kept saying what? Cruise control. When you cruise control, what does that mean? You keep the same what? And usually you also keep the same what? Although in cruise control, can you still steer? Yes. So technically, to Munir's point, and I always kept saying that, cruise controlling still allows you to what? To change what? Direction. However, if you really talk about legit uniform motion, you still have to keep the same what? Direction. So you're cruise controlling, but along one straight line. So uniform motion is when an object maintains or keeps or fixes the same speed and the same direction. Same speed and the same direction. By the way, it's important to say same direction because technically, everyone, when you take a when you go around a roundabout, are you still keeping the same speed? Yes, you could, but you're doing what all the time? Changing your what? Yeah, if you take a roundabout, even if your speedometer is reading the same value the whole time, you're not doing uniform motion. You are not doing uniform motion because one condition is violated, which is the direction condition. Okay? So another quicker way to say same speed and same direction is you just keep the same what? Velocity. Because basically velocity is a vector and the speed is the magnitude and the direction is the direction for the velocity. So whenever you say an object keeps the same velocity, you are really giving me two statements at the same time. You're telling me I'm keeping the same magnitude and I'm also staying in the same exact direction. No turns, no reverses, absolutely nothing. Straightforward the whole time. So that's the first kind of motion. Sorry, that's the first kind of that's the first kind of motion, I guess. The second kind is called what? Uniform what? What does that mean? Only one thing is going to change there. I'm still going to keep going in the same direction, but now what could I do to my speed? I am changing it. So I'm either what speeding up but I'm not turning. I am not turning. I'm still going forward the whole time. I'm either losing or gaining speed. So when an object maintains the same rate of speed gain or speed loss. By the way, we can now call it speed gain and speed loss instead of velocity gain and velocity loss. Why? Because I'm keeping the same direction. So I'm keeping 50% of the information the same. I'm just changing 50%, which is the amount. Oops, sorry. Yes. When an object maintains the same rate of speed gain and speed loss in the same direction. So what happens if both of them change? What happens if both the speed and the direction changes? Well, it's neither of those motions. But we don't deal with these motions in grade 12 physics. And you know why? Because you need calculus. So you only deal them in what? In first year physics. By the way, first year physics, the official name of the course is calculus-based physics. Almost every problem could be done purely as physics or with calculus as well. Okay? All right. So everyone, let's do a worksheet now where we deal with uniform motion and uniform acceleration. There you go. Let's read the statement of the problem. So a car is traveling along a straight, non-curved. Why do you think I'm saying that? Yep, Ahmed. Say again. Because I am basically telling you it maintains the same direction. So we don't have to worry about direction here. Okay. As shown below. Okay. Does the motion of this car represent uniform motion? How many people say yes? How many people say yes? How many people say no? Okay. Who said yes again? Who said yes? Okay. Who said yes? Okay. Umayma, you said yes? Okay. Can you explain to me why you claim that this car represents uniform motion? Wait a minute. Is it going at the same speed? Is it changing its speed? But is it keeping the same direction? Is that enough for it to be in uniform motion? In uniform motion, how many conditions do you have to meet? You have to meet same direction, which we do, but you also have to meet what? Same what? Is it meeting the same speed? No, it's not. Good. So the answer is what? The answer is no, it's not. So go ahead. Does the motion of this car represent uniform motion? No. And you can just say because the speed. You can say velocity if you want, but we can say speed now because we already maintained direction because the speed keeps changing. Done. That's it. Full mark. You use the keywords and you perfectly explained yourself. Is it representing uniform acceleration? Do you know that for sure? Can someone tell me again what was the only condition aside from the direction? What was the definition of uniform acceleration? Go ahead, Ahmed, read it from the slideshow. What was the definition? One sec. Of uniform acceleration. Go ahead. It's when the car maintains what? Say again, the same what? Rate. So we can't say it until we see the what? Until we calculate the rate. That's exactly what the next question is. Okay, let's do this, everyone. So for each time interval that you're given, determine the acceleration in what? Kilometers per? Okay, hour squared. Fine. Let's look at the first interval. Everyone, how long is the first interval? How long, time-wise, is the first interval? 20 minutes. 20 what? Minutes. But I want my final answer to be in? Great. We can do that within the calculation itself. Okay. Okay. First of all, can someone remind me again what's the equation for acceleration? What over what? Again, you have it in your third slide. Change of velocity over change over time. Velocity, is it a vector or a scalar? Velocity. Vectors need what? Did I specify directions here? Can we just come up with any direction we want? Yeah. You could make this east and west, or you could make it what? South and north, for example. Let's make it north. Everyone, go ahead and put north here. Go just to agree with the solutions I'm gonna post. So go ahead and post. Oh, sorry, I mean make north here, which means this will be what? All right. Okay. Let's write the equation. Okay. So A. Don't forget the arrow. Are we doing instantaneous acceleration or average? We're always doing what in this course, by the way? Average. By the way, the reason we don't do instantaneous in grade 12 physics is instantaneous velocity, speed, and acceleration need calculus. It's not a requirement for this course, so I can't ask you to do instantaneous. So please, always, everyone, always put AV at the bottom. All right? What's the equation? Well, I need a fraction sign, and it has to be VF minus VI divided by what? Not quite just time. Divided by exactly what? What does the equation say? From either TF minus TI or what? Or delta T. Did I give you a final and initial time, or did I give you the size of the interval? By the way, I am almost never going to give you TF and TI. I'm always just going to give you what? Delta T. Do you see what I mean? I'm always going to give you the size of the time, like the size of the stopwatch time, not the initial final stopwatch time. Okay? So let's just write delta t. Okay? Now let's put some numbers. Can someone tell me what's the final velocity of the car at the end of the 20-minute interval? What's the final velocity of the car after 20 minutes? How much? 8. You have to give me 3 things. You have to give me the number. You have to give me the unit. And you also have to give me the what? Direction. Thank you. By the way, I'm pretty sure so many people. Okay, how many people remember from grade 11 that I started always saying, you need to give me direction? And in a couple of weeks, what did you start doing? Not giving me direction, remember? You start giving me what? Either plus or? Exactly. But we have to start with the old school way first, and then we'll see how we can always what? Skip directions for signs. But that's next week. All right. Or actually, no. Actually, this is on this Thursday. So you'll see it very soon. Okay. What was the speed again? 87. So 87. Is it just 87 or 87.0? Sure. Okay. Kilometers per hour in the north direction. Subtract. What was the initial velocity of the same interval? Great. So go ahead. 75 kilometers per hour, also in the north direction. Okay. Divided by what? How long is the interval? But I need it to be in what? How do you go from minutes to hours? Do you multiply by 60 or do you divide by 60? You divide by 60 because you have to get a decimal, because 20 minutes is not what? Is not a full hour yet. So go ahead and you can just write 20.0 divided by 60. All right. Are the two directions the same? So can I just do what the math tells me? Yes, there's no need to flip. Not like that 1D displacement strip stuff. All right. What's 87? Subtract 75. How much? 12. Technically 0.0 kilometers per hour. Still in which direction? Okay. No, okay. You to Ali's point, you don't have to put 0.0 because technically it's an intermediate step. You're right. We're only gonna look at the sig figs at the end. However, everyone, remember the rules I taught you about adding and subtracting with sig figs? When you add and subtract, is it the sig figs that matter or the decimals? Decimals. So technically, one decimal with the first value, one decimal with the second value. You have to show one decimal with the second value. But I'm not going to ask you to follow those rules on this course. Although in first year, you might have to. All right. What's 20 divided by 60? Exactly. In quotation marks. It's a third, which means in decimals, it's an infinite number of what? It's a 0.3333 forever. Okay. So if you want to just keep it to, I guess, 3 sig figs if you want it. By the way, you are more than welcome to do this. Everyone, look. I am not going to take marks if you do it this way. 1/3 of an hour. Also, I'm not going to take marks if you do it this way. If you show me some decimals. If you do this, 0.333 of an hour. In fact, let's do it this way because that's the way I have my solutions written as. Okay? Next. Hours. Hours and hours do what? If you cancel, what's the only unit that survives? What do you measure using kilometers only? Distance. But the question is asking you to report what? Acceleration. Do you see what I mean? That doesn't make sense. Kilometers only measure distance. We're trying to measure acceleration. I can't report that unit. Okay? Perfect. All right. So it doesn't cancel. So erase, erase. So I'm just gonna what? We're just gonna do the calculation now. So what's 12 divided by 0.3333? It's exactly like 12 times a third. Sorry, times 3, which say again. Not quite. Oh, Amar, you're dividing 12 by 3. We're dividing it by a third, which is like multiplying by 3. Okay? So divide by 0.333, which is how much? Okay, up to 3 sig figs. What would that be? 36.0, which, by the way, is the exact answer you get if you divided 12 by 1/3 exactly. Okay? That's why some people like to use fractions within. because they don't have to go through all of that. But we're physics people, we do run into decimals. So 36.0 kilometers per hour squared. In which direction? Right. Oops, sorry. All right. I want you now to do the next interval on your own. Go ahead. Literally the same amount of work. In fact, here it is to show you exactly what to count. You just have different numbers now. Go for it. And once you're done, just raise your hand to compare the numbers. How many people are getting 36? How many people are getting something different? Okay. Obviously, if so many people are getting 36, 36 must be the what? The correct answer. Does that make sense? Yes, from everyone. Look, from two standpoints. Number one, how is it the same value, even though all the numbers are different? Question, everyone. How much speed did you gain in the first equation? But it took you how much of an hour? Sorry, how many minutes? How much speed did you gain in the second interval? 27. But it took you how long? So, so did both numbers also grow? That means, but they grew to give you the same what? Rate. Is that making sense now? That's why you have to what? That's why you have to get the exact same rate. Okay. So, Josh, does it actually represent uniform acceleration? Yes, we could not have said that unless we actually did what? Did that. Okay, let me show you the calculation. AV, don't forget the arrow, equals, I'm going to skip the equation, 114. By the way, I don't care if you skip the units, as long as you remember to put them in the final answer. How much is it? 45? 45 divided by 60 of an hour. What's 45 divided by 60 exactly? No approximation. 0.75, 3/4 exactly. So you are going to get 36.0 kilometers per hour in the note. Did I make a mistake? I did. Thank you. Squared. Good job. Nice chatting. All right. So does this motion represent? Yes. So let's write a quick explanation. Yes. Because the rate of, I don't want to call it speed gain, even though it is gaining speed. I'm going to call it speed change as a neutral term. The rate of speed change. By the way, you can call it velocity change. Speed change is fixed and constant all the time. Go ahead. Say again. No, 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 no. Okay. Uniform motion, if the speed change is 0, here the speed change is what? Is not 0, but it's constant the whole time. Okay. Okay. It is uniform motion if the speed is not changing. But we just saw that there is a speed change, right? But we even analyzed the speed change itself, and the speed change was the same all the time. You see the difference here. Okay, so it is not uniform motion, but it is indeed uniform acceleration, just because the rate of change is the same. Rate of change. Slope, like we did in grade 11. Okay? Okay, everyone, last one. Eyes on screen. Assume the car keeps what? Keeps what? Speeding up, keep accelerating. Half an hour after the 114. What's the new speed? Okay, what givens do I know? Do I know the initial velocity? Yes, how much is it? 114. Everyone, basically, look, we want this now. What if you start here and you end somewhere here? What's the new speed or the new velocity? Whichever way you want to say. Okay? All right. Let's write some numbers here. So, what's VI? What's my initial speed now? It's not 75. It's not 87. It is the what? It is the what? 114. So go ahead. 114 kilometers per hour. In which direction still? All right. How much time am I given the problem now? 30 minutes. But it needs to be converted to what? How much is 30 minutes from an hour? Done. So delta t, go ahead everyone. Delta t equals 30 minutes, which is equal to, I don't really care if you write it as half or 0.5. Let's do 0.5. 0.5 hour. And I'm telling you, it's keeping the same what? Which is the same what? Acceleration. So go ahead. AAV is still how much? 36 kilometers per hour squared north. If I know the VI, what am I missing? The final velocity. Okay? Can I set up my equation? Yes, I can. But which variable am I missing now? Yeah, but remember, there are 4 variables. A, VF, VI, delta T. I know the delta T. I know the VI. I know the A. Which one am I missing? The final, which means if you have 4 and I give you 3, you definitely can solve for the last one. I'm going to show you how the final answer looks like. Worksheet solutions, 6. There we go. Oops, sorry. There we go. What am I going to end up doing? Of course, 2 fractions equal to each other, cross multiplying always comes to the rescue. So go ahead. A, V, I, delta T, VF. So what did I do? How could I solve this equation? I have to do what with this? I have to what? Move it. But when I move it, it becomes a what? Interesting. How does this answer make sense? Should your speed after the 114 be lower or higher? Of course, because you're still gaining speed. Makes sense? You are higher. Perfect. Done. That's your only logical check. Obviously, I do not need therefore statements, but I encourage you to write it in your notes just to keep it there. But you're not going to lose marks if you don't write therefore statements. By the way, do you see what I wrote here? The what? The speed. I didn't say what? I didn't say what? No. The velocity. Because if I said velocity, I can't just say 132 kilometers per hour. I have to say what? I have to say a what? A direction. Remember, exactly. But the question asks for speed. I don't want. By the way, everyone, just so you know, most of the time, I'm going to ask you to find speed, not velocity. Okay, most of the time. Sometimes I might ask you to find velocity, but most of the time, we're just going to keep it scalar. Well, let's do a 2D. Let's go back to your handout, your slide. Let's do a 2D problem with acceleration. So the question says over a 15-minute period, right there, that's your what? 15 minutes, that's your what? Change in time. Go ahead, everyone, and just call it delta t. So right on top of it, delta t. Delta t. All right. So over a delta t of 15 minutes, a truck traveling on a road with many turns. Okay. However, at the beginning of the 15 minutes, what was the initial velocity of the truck? At the beginning of the 15 minutes. How fast was it going and in which way? It was going 50 kilometers per hour. And which direction? West, 60 north. So everyone look at my hand. West, 60 north. So 60 degrees here. Okay. At the end of the 15 minutes, we saw that the truck speed was how much? 80. And its direction of traveling was what? east 60 north. Okay, that's fine. By the way, everyone, look, this is what it means. Check this out. Um, so initially the truck was going this way, right? Was going this way, right? Because this direction is what? This direction is west 60 north, right? It's going up and left. And apparently after 15 minutes, it was going which way? This way, right? Because that's east 60 north. So apparently over 15 minutes, it turned this way. Does that make sense? And by the way, did it keep the same speed or did it end up at a faster rate? What was the final speed? So apparently it started at 50 there down below. And as it was what? As it was turning, it was also gaining what? Gaining speed. You got it. The question is, what's the truck's acceleration in what? Per hour. So that means we need to switch this to what? Out. Is this one good? Is this one good? Perfect. So we just need to what? And by the way, what's 15 minutes out of an hour exactly? No approximation. 0.25. It's 25% of an hour, or 1/4. Okay? All right. Do you think we need a diagram here? Of course we do. Why? Because we have vectors. And our vectors, by the way, are those good vectors or bad vectors? Why? They have an angle to them. They're not perfectly west, perfectly north, perfectly east, or perfectly south. Okay? So, all right, everyone, you have the grid right here. Although you don't need one. Who wants a ruler? Anyone? I'll just give one for table. Chair. Who else needs one? Another table, maybe. You need one? Oh, you're good. Okay, I have enough. Okay, so go ahead. Sketch this vector. Is this the west or the east one? That's the west. So can someone tell me where's the 60? Is the 60 here or here? Is it up or below? Exactly, because you went west. What if it was north 60 west? Then it would be where? It would, because you'd go north 60 west. Okay, go ahead. By the way, do you notice how I sketched that vector? Is it a solid or a dashed one? You're gonna know why. Just hold on. Go ahead, make it dashed. Make sure you're actually doing it dashed as well. Okay, and apparently the V initial is 50 kilometers per hour. Okay, what's my next vector? Come on. Where does my other vector point? What's east 60 north. So what do you think is going to happen? It's going to be perfectly a mirror image of the what of that one. But what about the magnitude? Would it be the same length, short or long? Because it's a bigger speed. Yes, good. Nice. By the way, sketch that one as what? As solid. Again, you're going to know why in a few seconds. Can someone tell me what the equation for acceleration is again? Anyone? What's the equation for acceleration? Say again? Change in velocity. Can you tell me the more detailed equation? Basically, you just told me delta V. But what is the actual mathematical equation? Vf is it plus or minus Vi? Can someone tell me what happens to a vector when you precede it with a minus? Does anyone say it? Question. Okay, everyone, eyes on me for 30 seconds. My location is 0, right? Let's say my location is 0. If I tell me which hand to put out to go to +5. To you, which way is plus? Left or right? To you. So which hand should I put for +5? Okay, right? How about -5? What happened to the vector? It what? What's another word for shift? Starts with F. Flip any vector with a minus, you end up what? You end up what? Flipping it with how many degrees? When you go from here to here, how many degrees did you go? 180 degrees. That's why I sketched this one as what? As what? Dashed, because I'm not going to use this one. Which vector am I going to use? The what? The what? The flipped one. No, no, no. It's still going to be initial, but it's going to be what? It's going to be what? Flipped. That's the whole idea. Everyone, every time you have a negative vector on a diagram, just what? Just flip it, and that is the new vector that you use. So go ahead. Did you see what just happened? It used to be here, and it shifted perfectly. Oh, sorry. Go ahead, sketch that one. Those are the two vectors we're going to add up. Everyone, now we're going to add, not subtract. Subtraction means what? Just flip the other one and add them up. 50, of course. Why do you think I'm choosing north and east as... By the way, does it make sense to choose east as positive? Yeah. Is anything any more pointing to the west after flipping? No? So good. Everything is pointing east. Why do you think I should point... Why do you think I should choose north as positive? Which vector has a bigger component on the vertical? The north one or the south one? If you break them down, which one has a bigger component on the vertical? The north, exactly. Look, everyone, when you break them down, this one is going to go up to here, and this one's going to go up to here. This one's going to go down to here, but that one's going to go what? Higher. That's the whole idea. So, oh, sorry. Okay, let's do the breakdowns, everyone. Come on. So, where's my breakdown? Well, first of all, sorry, 2, 3, 10. Okay, breakdown. 1, 2, 3. Breakdown again. Sorry. Breakdown again. Breakdown again. Okay, you have a whole slide to write the calculation. I don't. So whatever, everyone, whatever I'm gonna write here, everyone, whatever calculation I'm about to write, I just want you to write them here. And if it overflows, you have this one as well. All right. First, let's add. Oh, we said positive and positive. Okay, so everyone, let's do the vertical. So go ahead and write vertical. So VERT. VERT for vertical. Can someone tell me, is this going to be, everyone, is this, sorry, is this going to be cosine or sine of this 60? How many people say it's sine? It is sine. You know why? Because it's what? It's opposite. This guy right here is as big as this guy. And that's sine because it's opposite. So everyone go ahead, and I just want you here to write 80. Go ahead, 80 sine 60. Which means this one's got to be what? 80 what? 80 cosine of 60. How about this one? 50. Again, it's opposite. So it's 50 what? Sine of 60. And that short one here. So I'm going to erase this guy. Eraser. This one is going to be 50 cosine of 60. So can someone tell me what am I going to do on the vertical? Am I going to add them up or subtract them? Look at the ones on the vertical. Are they going together or against each other? Look at this one. Sorry, look at this one and this one. Are they going with each other or against? Against. So that means what? Your vertical is going to be 80 sine of 60 subtract 50 sine of 60. 80 sine of 60, 50 sine of 60. What's the common factor between those two expressions or terms? Sine of 60. So you can say, oh, that's just 30 sine of 60. By the way, you don't have to do that. You could just plug in the numbers now. 30 sine of 60. Yeah, I need someone's help now. I know the sine of 60. Go ahead. Who's got sine of 60? Come on, just plug it in. It should be the 0.8660. So I want someone to multiply sine of 60 by 30. Go ahead. What's sine of 60? Make sure you're on degree mode, not any other mode. So yeah, it's 0.8660, right? 0.8, it has to be because it's through 3 over 2. Yes. Times 30, what'd you get? Marah got 25, 98. Okay, good. So everyone, 25, 98. Okay, let's do the horizontal now. Horizontal. What are you going to do with the horizontal one? Are you going to subtract those two or add them up? Because they're what? They're going what? Against each other or together? Perfect. We're going to write the exact same thing, but instead of signs, we're going to use cosines. And instead of minus, we're going to use a plus. So go ahead. 80, 80, cosine of 60. Sorry. Sorry. Let me go again. 80 cosine of 60 plus 50 cosine of 60. What's the common factor again? Cosine of 60, which will be 80 plus 50 is 130. Yes. 130 cosine of 60. Guess what? Cosine of 60 is a perfect half. So that will be what? Half of 130 is 65. Right? 65. Okay, good. Okay, I'm gonna stop right here, but just in case, if you what we're gonna do now is we're gonna do the Pythagorean theorem with the 25.98 and the 65. Do the Pythagorean theorem, and then do the angle, and then divide the whole thing by the time to get the what to get the acceleration. I'll finish this in tonight's video. Don't worry, or today's video. 130. Sorry, yeah. This is the sorry. This is the diagram. Yeah, this is sorry. This is for the diagram. My bad. See you.